So we're about to start into the organic chemistry unit that has two distinctive pieces. A big piece is knowing how to name and draw organic compounds. The other piece is reactions of organic compounds and their properties. The properties is largely a recap of Chem 20 intermolecular forces. So that'll be coming in 5 or 6 lessons. Organic chemistry is a 20% diploma weighted exam, or 20% weighting in this course. So you'll see that on the diploma, and you'll see that in the weighting of your unit tests. Okay. So organic chemistry is the study of carbon-containing compounds. It has nothing to do with like organic food you might buy or food that's not organic. It's a very historical definition. Two terms that are going to be applied very rigidly. You should really take note of these on tests or quizzes. If a question says identify the hydrocarbons, we are looking for C's and H only compounds. So that might be something like methane. Okay? That only contains carbon and hydrogen. The count doesn't matter, it's still a hydrocarbon. Hydrocarbon derivatives have some other element. So carbon, it doesn't even have to have any H's, but it has to have something else. So we'll talk about several options of oxygen, alcohols, carboxylic acids, or X is referring to group 7A or group 17. Those are your halogens. Okay? We'll look at adding chlorine, fluorine, bromine, iodine into hydrocarbon derivatives. Okay? We can't have those in hydrocarbons because they're not C's and H's. Now, there are some carbon-containing compounds that are not classified as organic. Okay? You know, the organic is coming from the living world, the biological world, and there are some organic forms that aren't part of organic beings or cells. Okay? This is a outcome of the course. You know this will be on a test or quiz. You need to recognize that ionic derivatives of carbon, such as carbonate, are not classified as organic. So carbonate is CO3 2-. Okay. Cyanide, CN-. Okay. Cyanide is not considered to be an organic compound or derivative. Okay. And carbides are metals plus carbon. And then there's another bullet. All the oxides of carbons aren't considered to be organic. So you have carbon dioxide and carbon monoxide. Okay. Sort of everything else you're going to see with carbon is deemed to be classified as organic. Looking at a couple examples of what's not organic and a little bit more detailed or quiz-like, you're not just going to be asked whether carbonate is organic. You might see something like sodium carbonate. So that's an ionic compound, contains sodium ions and carbonate ions. Once you recognize that carbon is part of a carbonate, you're going to say that that is not organic on an assessment. Okay? Same way cyanide. Okay? You might have hydrogen cyanide, or you might have potassium cyanide. Doesn't matter what's with the cyanide, it is not organic. Okay. Last, the metals and carbon, they don't show up on assessments as much. Okay. But you could have tungsten carbide. Okay. It is very likely the diploma, when they write a question based on this outcome, carbonate, cyanide, carbon dioxide, carbon monoxide are the most likely choices that they'll use. But they could use a metal and carbon. Okay. That's kind of a little bit of what's not organic. I'm not going to mention this again, but you have to remember to look at this before you write that diploma unit test or you write your first quiz. Okay. We're going to recap a little bit of Chem 20 bonding, and then we're going to jump into the world of hydrocarbons first. We're going to spend several days on just C's and H's, and then we'll add some oxygen in the 3rd or 4th lesson. So our Chem 20 sort of bonding review. Okay. We have nothing ionic in our organic compounds. Everything is going to be molecular bonding, sharing electrons. I want to recap how many bonds different atoms have. The Lewis structures remind us of how many single electrons we have and how many bonds we're going to get. So I'm going to draw out the Lewis structures for group 4, 5, 6, and 7. So the most important element is obviously carbon. Carbon is has the symbol C, and carbon sits 1, 2, 3, 4 atoms over in the periodic table. It's group 4A. So that tells us how many dots go in the Lewis symbol. We start by spreading the 4 dots out, top, bottom, right, left. Then if we had a fifth one, would start pairing them up, but we don't have a fifth valence electron in carbon. So carbon has 4 singles, and as a result, you need to remember that it always has 4 bonds. Now in chemistry, we use bonds, we represent them with dashes. So carbon is always going to have 4 dashes coming out from it. Okay. Now they can pair up or triple up, but they'll still be 4 dashes. If we move over a group to group 5, nitrogen has 5 valence electrons. 1, 2, 3, 4, and then the fifth pairs up. So nitrogen only has 3 singles. So nitrogen will form 3 bonds. We're never going to have 4 dashes or 2 dashes. Unfortunately, we don't do a lot of nitrogen compounds in high school. You see a lot of them in biology with biological molecules. We will use oxygen a lot in this course in group 6 with 6 valence electrons. That's 4. The fifth is going to be a pair, and the sixth is going to be a pair. There are 2 single electrons in the Lewis structure or Lewis dot diagram for oxygen, so we end up with 2 bonds in oxygen. So we've got 4, we got 3, we got 2, and then we move to the halogens. The trend continues, 4, 3, 2, 1 bond for chlorine. It's in group 7A, so 7 valence, 1, 2, 3, 4, 5, 6, 7. It's only got that 1 single, so we're going to put 1 bond. We're not going to write any of those dots. That was Chem 20. We're going to jump right to the dashes, 1 dash, 1 bond. Hydrogen in group 1, like chlorine, has 1 single. We're going to have hydrogen in all of our organic compounds or hydrocarbons, and we're always going to put 1 bond, and we can never put hydrogen in the middle because you can't put something that has 1 bond in the middle. It can't go in more than one direction. Hydrogen has to be at the end. So that's kind of our Chem 20 building blocks. I'm going to draw a few molecules similar to Chem 20, and then we're going to start moving into different families, organic families of molecules. Okay. So CH4, we'll learn how to name this. It'll be called methane. Everything that has 1 carbon has meth as its stem or the heart of its name. So we see CH4. Okay. Hydrogen can only have 1 bond, so it has to be on the outside. We've got carbon that's going to have to be in the middle, and we know carbon needs to have 4 bonds, so we represent that with 4 dashes. CH4, the reason there's 4 hydrogen is to match up with carbon's bonding capacity. Okay. You can't have CH3 and you can't have CH5. It doesn't work with how carbon bonds. This in Chem 30 is what we call a structural diagram. We'll learn 3 distinctive diagram types. The first is the Chem 20 type. I'm going to build up in complexity in my 3 examples. C3H8. So we went from 1 carbon to 3 of them. Now, when you have carbons and hydrogen, all the carbons have to go in the middle. Okay? There is no way, do not write this, but you can't go carbon to a hydrogen to a carbon. Hydrogen doesn't do that. Okay? That's 2 bonds, which is incorrect. I have to have just 1. So your default would be to line up all the carbons in a row. This will always happen for hydrocarbons. Now, there could be a double or a triple. We're going to use bonding capacity to help figure that out. I'm going to look to see how many more bonds would these 3 carbons have. If it's 8, then they're going to get filled with hydrogen. Okay? If there were only, if there were more or less, then we're going to have to think of double bonds to potentially get the molecule to work. So our very first carbon has 1 bond already. It's going to need a second, a third, and a fourth. The middle one needs 2 more bonds. The N carbon has 1 already. There's 2, 3, 4. So I want to see, this may or may not be the correct answer. How many bonds are there? 1, 2, 3, 4, 5, 6, 7, 8. There's 8 dashes. There's 8 hydrogen. So this is going to match up. We don't need any doubles or triples to make this work. So the heart of these drawings is that every carbon has 4 bonds, every hydrogen has 1. You can't deviate from that. Okay. So we're going to have to do something a little bit different with the last example. C2H4. You'd start by putting those 2 carbons together, and we'll see how many other dashes there are needed. So there's our 2 carbons. Now I'm going to have to do some erasing, so I would wait before you write. If I think of how many more bonds are needed, the N carbon on the left needs 3, the N carbon on the right needs 3 more, but I only have 4 H's. So what I've started to do isn't going to work. Okay? We don't have 6 more things, we only have 4. We've got 2 bonds that can't go to hydrogen. Well, if we've got 2 bonds that we don't have outside atoms, we've got to connect them up. So I took away a dash off each carbon, and I can put them not out to something else, but to each carbon. Each carbon now has 4 dashes coming out of it, so that's good. There are 2 dashes with no atoms, and that's where 2 H's go to the left and 2 H's go to the right. And this is the structure for what we'll call ethene when we get to the naming. There's a double bond to make this work using bonding capacity. Now my bond angles aren't correct. You're not going to get tested on that Vesper theory, but each of those carbons from last year would be trigonal, planar, and 120. Okay? Again, but you don't have to worry about that. Okay? But you cannot put 5 bonds, you can't put 3. You're going to get big circles on quizzes and axis. That's not right. Okay? So that was a bit of last year. We're going to start jumping into this year. Okay? Where the heading was Chem 20 naming. This is not given in a data booklet. You need to know the prefixes, the stems for the first 10 carbon counts. If you have an organic molecule and there's 1 carbon in it, you're going to see meth in its name. So if the longest chain of carbons is 1, it's a meth. Okay. You can have branches coming off hydrocarbons, Ys, forks. Okay. We'll see that shortly. If you have a branch coming off that's 1 carbon long, you still use meth, but you add a YL to tell the reader that's a branch, not the longest chain. So 1 carbon meth, 1 carbon branch methyl. 2 carbons is F, unless it's a branch of 2, and then we call it methyl. If you have a barbecue at home and you go and fill up your tank with propane, you're using the prefix for 3 carbons. Propane has 3. So prop and propyl for 3 in a row, or the branch of 3. 4 is bute. It's not but. It's bute and butyl. Then we're into our polygon shapes. So if you remember your elementary shapes, 5-sided is a pentagon, so pent, hex for 6, hep for 7, oct for 8. And I'll scroll down in a second. Non for 9 and dec for 10. So I've hidden meth and F, and now we can see 9 or 8 was a bit hidden. 8 is oct, same as an 8-sided shape is an octagon, non and dec. These are very similar to those Science 10 molecule prefixes, but they had an A on them. So it was non-A and dec-A. That A isn't there in organic chemistry. So I want to give you a visual in a second. What do I mean by stem, longest chain, and branch? You need a visual for that to make a bit more sense. So I'm going to draw a long chain, or a 4-carbon long chain. Don't worry about VSEPR theory and the true bond angles. We draw a lot of things straight before we name them. That's 4 carbons long. Then I'm going to put a very short branch coming off that. I'm just going to do a 1-carbon branch going up. Okay. Then I'll have to fill in all my hydrogens. Every carbon has to have 4 bonds. So I'm going around the molecule, counting to 4 around each carbon. Okay. The longest chain we call the stem. So if I go 1, 2, 3, 4, there's nothing longer than 4. I could go 1, 2, 3, up 4, but it's a tie. I've got to pick one. I'm going to pick this as my longest chain. There's nothing longer. So how are we going to name that? You're going to see bute show up in its name for the stem. Okay. We're not going to put all the pieces together quite yet. Okay. Another piece is going to have to be naming that side group. Okay. Now I'm going to very consistently use the type of writing I've done here. I'm always going to snake, kind of circle up the stem, and I always put boxes, squares or rectangles around my branches. Okay. That is a Mr. Curtis thing, not a rule that you have to do. This is just a strategy to help decode the naming. That branch only has 1 carbon in it. Do not count the hydrogens. There's 1 carbon, so that would be a methyl. Okay. The YL only showed up in the side branch name. It didn't show up in the longest chain. So we're going to see methyl, we're going to see bute, and then we're going to see endings to tell us whether they're single bonds, double bonds, or triple bonds. And that's what's coming next, that piece of information. Anes for single bonds, enes have a double bond, ines have a triple bond. Okay, so we're jumping into our very first family. This is sort of the heart of the unit and the structure I'm going to teach. Anes are called a family. Okay. You might be given a molecule and said, what family does that belong to? Okay. Anes are organic compounds, so they have carbon, and they have to have carbon and hydrogen only. So they are hydrocarbons. Okay. You can't have oxygen or nitrogen or chlorine. Okay. And then last important part of this family is the carbons must be connected with single bonds. So no doubles or triples in this family. So I have a structural diagram on the board, and we're going to name it in a second. Now I use software to draw this structure for me, and the software followed Vesper theory with the bond angle. So that's why it's zigging and zagging. So it's Chem 20, 109.5 bond angles. So to name this, we have to find the longest chain of carbons. I'm going to ignore the hydrogens. I'm going to start doing my snake. And at the branches, I'll have to count each way. So I've got 1 carbon, 2, 3, 4, 5, 6, 7, and I hit no branches. All of these are continuous. At no point is there 2 offshoots with carbons. So to name this, 7 carbons, you'd have to remember that chart, and 7 is hept. Then you'd look at all your carbon-carbon bonds. All the CHs have to be singles, so we're not even looking at those. All of those bonds are singles. This is a member of the ane family, and ANE is the ending that goes after the stem. So that name is heptane. We'll do another example in a second, but I want to talk about some different structures. I want to introduce the second type of structure. Now, you're going to see lots of examples of this and have to fully understand it before your first quiz. So I'm going to do a condensed structure. Condensed structures get rid of all the dashes and just tell us what sequence of atoms do we have. And from this, you should be able to name it or decode the structure. So our very first carbon has 1, 2, 3 H's around it. So we're going to condense everything together. There's no dashes. We got a carbon and 3 H's, and then we're going to move on to the next carbon and do a count. Now I want to keep track visually of the carbon. So that one's done. I'll move on to the second one. There's our second carbon, and there are 2 H's. So that's CH2. I move on to the third carbon, and there's 2 down H's next to it. I move on to the next carbon, and there's 2 carbons up. The up doesn't matter. I'm just keeping track of where they are. Now we're back to some 2 down H's next to that carbon. Our 6th carbon has 2 H's. And then we get to our 7th and last carbon, and there's 3 H's at the end. So that would be the condensed structure of heptane. No branches, all single bonds. And when we've no branches and all single bonds, we see 3 hydrogens at the end and 2 hydrogens all the way through the middle. Okay. So we've got structural from Chem 20. We now have structural and condensed. And I'll introduce line structures in the future. Another example, and this one has a branch in it. We've got 1, 2, 3, 4, 5, 6, 7 carbons, but 2 from the right is another carbon coming off, going up. So we have a branch here. We're going to have to use one of those YL names. I'm going to start trying to find that longest chain. 1, 2, 3, 4, 5, 6. And now I've got to look both ways on the branch to see what is the longest. No rule says you go right to left. You find the longest. It could be in a C shape. It could be in an S shape. It could be up and down. It could be right to left. It doesn't matter. If I go this way, 1, 2, 3, 4, 5, 6, 7. If I go up, it's also 7. It's a tie for the longest. When it's a tie, you can go either way. You'll get the same name. So I'm going to go that way. That is one of the longest chains. I've got some carbons off that longest chain, and it is a single carbon. When you put your sort of snake and your boxes, they can't overlap on the same carbon. You can't double count the same one. That blue box cannot go over the red. So what's the stem? That's the same as before. We've got 7. So this is hept. We've all single bonds, so it's a heptane. And now we have to deal with that branch. That branch is 1 carbon. So it is a methyl. Now the branches go first in the name. So it's branches, stem, family is the sequence. And we're actually not quite done. We have a little bit more to add in. We're going to keep building up in our complexity and getting more and more rules. A name should tell us the precise instructions to draw a structure. And we do not have precise instructions. We know there's a branch of 1. We know there's 7 carbons in a row. We know there's single bonds, but we don't know where that branch is. Just from this instructions, we don't know whether the methyl is in the middle, at one end. We need a number to tell the reader where the branch is located. The IUPAC rules, the international body that makes up the rules, says you have to count from the end that gets to the branch with the smallest number. So we've got 2 options. I'm going to erase one of these stars. That's one end. That's one end. And we must go with the end that gets to the branch the fastest. So that is pretty clearly the one on the right. Okay. So we need to count carbons from the right because that's the shortest path to get to our branch. So I'm going to number those carbons. You often will just count in your head and not number. That is the very first carbon. The branch isn't off that carbon. There is our second carbon, and that's where the branch is. So the branch is off the second carbon, so we put a 2-methyl to tell the reader that's where it is. And that's the complete name, 2-methylheptane. We're going to take another little leap ahead in complexity, and I'm going to throw 2 branches in instead of 1, and we'll deal with that. And then we'll get some of the rules. Okay. Now I've done a little bit of a condensed structure. I haven't fully condensed it, but I condensed all the H's. I'm not going to write this on my board, but that is not a structural diagram because every bond is not shown. Okay. I intentionally didn't use a structural. This is clearer and cleaner, I think, for you to look at. Now we have quite the branch there. We've got kind of a three-way branch or a four-way branch, a four-way intersection on one of those carbons. First thing is find the longest chain. 1, 2, 3, 4, and then I get to my branch, and if I go up, it's 5. If I kind of go up to the right, it's 5, and if I go to the hard right, it's also 5. Doesn't matter where I go, the longest chain is going to be 5. So that's our stem. And then we have to branch up any side groups. Okay. Now we can't go through the purple. Okay. And when you kind of block out what's in the purple, there are two separate dashes coming off our molecule. We have this one coming off our stem, and we have that one. Okay. We'll see in the future 2, 3, maybe 4 carbon branches coming off, but those both, they're two separate single branches. So the stem, you've seen that name, so this is going to be as before, 1, 2, 3, 4, 5. So that's pent. All single bonds, ane. We've got 2 branches. They're both methyls. Now to try to keep things cleaner and simpler, we're not going to go methyl-methyl. Okay? We get these crazy big names. Okay, we want to simplify this. We're going to use some prefixes. If there's 2 of something, we'll just say di. 3 of them tri, 4 of them tetra. And this will come in your notes later. So we've got 2 methyls, so we're going to use di. Now we're not quite done because we need locations of those methyls. When you write di, it means you need 2 numbers separated by a comma. So I have blank, comma, blank, dimethylpentane. And we got to count and see which carbons those methyls come off. So this is my first carbon. This is clearly the shortest way to get to that branch. If I start from the left, I'm going to get bigger numbers. And a UPAC says that's wrong, and a test will mark that wrong. First carbon, second carbon. So the right-hand methyl comes off the second carbon. The left-hand methyl also comes off the second carbon. They both come off the same carbon, so they're both in the 2 position. So this is 2, 2 dimethylpentane. Okay. So that's pretty much the end of the intro ane family. I'm going to sort of give you all the long rules of how to name the anes, the enes, and the ines. Some of you will like nice rules that you can follow. Many of you will just learn by observation and having me do examples. Okay? But no matter how you learn, by observation or by the rules, you should be able to name everything. Okay? So what are the rules that I've been going through? So these are going to name the anes we did and the 2 families that are coming up next. Okay. So the first thing I always did was find the longest chain. Okay. And I named that. I used the stem name, oct, prop. We had a bunch of heps, and then we added an ending, a suffix. So far, we've only seen the ane ending for the ane family with single bonds. Shortly, we'll see an ene ending when there is a double bond, or an ine ending when there is a triple bond. For the anes, you don't need any extra numbers because you don't have to tell the reader where the single bonds are. They're everywhere. When you get to the enes and the ines, you have to tell the reader, where is the double bond? Where is the triple bond? And we'll see an example of putting in a number for a double or triple bond. And then we'll get to the branch rules. I'm going to do a 4-carbon long example with a double bond. 1, 2, 3, 4. And I'm going to put the double bond at the very beginning. Then I have to draw in all my H's, making sure I don't put 5 bonds around a carbon. So we've got to do one extra step that we haven't seen before in the anes. Would find the longest chain. That's not new. Now, when you have a double bond, you must include it in the longest chain. So it becomes find the longest chain with the double bond in it. Okay. Here, there is just a straight chain. So 4 carbons, what is that? We got meth, F, prop, then bute. So 4 carbons is bute. Okay. We've got a double bond. We're going to have to leave some space for a number now. The double bond is a member of the ene family, not the ane family. Okay. Now that double bond could be in many different places. Okay. We're going to do a slightly different count. We're going to count carbon-carbon bonds now, not carbons. So alkyl groups, you count the carbons. Enes and ines, you count the carbon-carbon bonds. So what side am I going to count from? It's not going to be the right-hand side. That's the longest way to get to the double bond. I'm going to put a star and count on the left. I always put a star as a visual aid on my notes to say where I started counting. As we put more and more things in, we could have a double bond, we might have some oxygen, we might have some chlorine. We have to always keep counting from the same side. We can't flip-flop halfway through the question. And that star is a good reminder to keep counting from the same side. So this is my first carbon-carbon bond. Don't count the C to H's. That's the first carbon-carbon bond. That would be the second one. That would be the third one. There's always n-1 carbon-carbon bonds, where n is the carbon count. So if there were 10 carbons, you'd have 9 bonds. 2 carbons, 1 bond. 3 carbons, 2 bonds. So that double bond is in the 1 position. So that is bute 1-ene. Okay. If you counted from the right, you might call it bute 3-ene, and you'd be incorrect. That is probably an incorrect answer on a diploma. Okay, you might have butene, bute 1-ene, bute 3-ene, and then maybe prop 1-ene is the last wrong answer. Okay. So you got to be careful on tests because there's going to be all of these answers that are close, but not quite the correct answer. So that's the longest chain with enes and ines. We've got a bunch of rules to go through for the branches. You must name and star for the double and triple bond first. That is the first thing you do. That's the first priority. Then you can deal and box up all your side branches, which are referred to as alkyl branches. C's and H's coming off the stem. Okay? And you're going to need to know their positions. What carbon do they come off of? Maintaining the side you've been counting from. You're going to add a number followed by a dash. Then the alkyl group. So number, dash, alkyl group name. I've seen this a few times. This would look like 3-methyl, okay, 3-methyl number dash alkyl group name. So second situation, possibility. Okay. There's 2 of the same alkyl groups in the molecule. Doesn't matter whether they're off the same carbon. Just somewhere in the molecule are 2 propyls or 2 methyls. Okay. You're going to name them together. Okay. You're going to use a prefix. Okay. So when there's 2 of them, we see that di prefix. If there were 3 of them, we'd see tri. Okay. Now, as soon as I see a student write di as a prefix, I'm expecting 2 numbers. If I see tri, I expect 3 numbers. If I see tetra, you're telling me there's 4, so you better give me 4 numbers for the position of all 4. 2, 5 means they're not on the same carbon. The second carbon from an end and then the 5th one over from the same end would have methyl groups. So what if there's more than one type? You've got a methyl and you've got an ethyl. Okay. I'm telling you to put them in alphabetical order. And this is about as complicated of name as you're going to see. We've got 2 ethyls and we got 1 methyl. Now in the name, I'm looking at the ethyl and the methyl. And since E comes before M in the alphabet, I put the ethyl name part first and I put the methyl name part second. Doesn't affect the numbering, okay, but it does affect the order. Okay. Later, we'll get into ring structures or ties. Now, if you have a tie to get to an alkyl group, you can also use alphabetic to break the tie. Now, there are 2 different systems. I'm only teaching you one. If you read the textbook or you read some information online and you learn the other system, I mark both of them right on a test, okay? But I'm not teaching you the 2 different ways. I'm only teaching you the alphabetic way. Okay? No student wants to learn 2 different methods at this point. Okay? So our last rule, a rule that I love but doesn't show up in tests a lot. But it shows up in names when you get them, and there's missing information. You're like, why isn't there a number? Mr. Curtis said there's supposed to be a number. Okay, we're going to check to see if any of the numbers are not necessary. Okay, if there is only one possible number, okay, so you go to do a number and you put a 2, and you're like, there's no way I could have a 1. There's no way I could have a 3. The only possible number I could have with that stem name and that ending is a 2 or a 1. You don't put the number. Okay? The number is dropped. Okay? An example where you would do this is in this molecule. There are 2 carbons, so that's F. It's got a double bond, so it's an ene. And if you followed all the rules except number 3, you'd call it F1-ene. Okay? But you can't have an F2-ene. There isn't even a second carbon-carbon bond. So IUPAC says don't bother putting the number in because it's not necessary. There's no other possible number. So the correct name for that is just ethene. Something you have to watch out for. When you go to put those numbers in, do that little mental think of whether I can drop it. It's dropped a lot in the 1, 2, and sometimes 3 carbon long molecules. When you get longer, you tend to need the number. Last thing I have is I said all those prefixes orally, but it's important to have them in your notes. So if you have repeated alkyl groups, we don't use a prefix when there's 1 of them, but if there's 2, di, 3, tri, 4, tetra. Okay. So can we name is the competition? Can we name that? Sure we can. We just got to follow the rules. What's the first rule? Where do we start? Longest chain. Okay. Find the longest chain. You got a lot of possibilities to count. Once you find the longest chain, or once we find it, then I'm going to finish this off. So let's see if in a minute you can draw and figure this out. So let's find that longest chain together. I'll fully name it, and then I've got another puzzle for you to try to solve. It looks pretty clear that I have high confidence that's part of the longest chain. And then I've got to go 3 other ways. So I can easily erase them. 1, 2, 3, 4, 5, 6 is where I've ended off. 7, 8, 9 if I go that way. 7, 8, 9 if I go that way. So I've got a 2-way tie. 7, 8, 9, 10 if I go down. That beats the 9. You had to go down to get the longest chain. Okay. I and possibly the diploma writers aren't trying to be mean, but we're going to try to trick you. Your bias is to go right to left. And that's just not a rule. It's a bias. Okay. You've got to zig and zag to get the longest. And I ended up with 10. That is the longest you have to be able to name in this course. So we have a decane, and then we got to deal with the branches. So I'm just going to pause, give you about 30 seconds to see if you can deal with the branches, and then I'll put up the correct answer. You got to think of what end should you start numbering from. So hopefully you're starting to figure out what end to number from. I'm going to box up my alkyl groups. Now I'm just concerned about the C's and the H's. Okay. I can't include that carbon in an alkyl group because that's already a red stem carbon. And then I've got another alkyl group there. Those 2 blue boxes aren't connected together. There's a stem in the middle in between them. So they're separate. So we have 2 of the same length, and they're 2 carbons long. 2 is ethyl. There's 2 of them, so it's a diethyl, and we need 2 numbers. So which end do we count from that end, or do we count from that end? If I count from the far right, 1, 2, 3, 4, 5, 6, 7. If I count from here, 1, 2, 3, 4. Well, 4 is less than 7, so that is the correct spot I have to count from. Our first carbon, our second carbon, our third carbon, they both come off the 4th. You must put the number twice. 4,4-diethyldecanes is kind of, I think monster is unfair. Okay. But this is as big as I can get with a parent or stem. Parent and stem are synonyms. They have the same meaning. I tend to use the word stem. Okay. So one puzzle done. This was sort of big and mean. The next one is small and mean. Can you follow the rules and get the name for this guy? And see if you can do rule 1, 2, and 3 properly. Okay. So, what's the longest chain? We got a whole bunch of ties. 1, 2, 3. If you go up, it's also 3. And if you counted top that way, it's 3. So I have to pick one of the longest chains. I'm going to pick that one, which leaves one extra carbon, a methyl. So we have a propane, all single bonds. We've got a methyl. Okay. What position is the methyl? Second carbon. So that's where you'd be after rule 2. Now, could we have the methyl in the 1 position and still have a methyl propane? So what would happen if the methyl, I can't physically do it, but if this methyl was over attached there, it would be at the end, and it would be just part of the stem. It'd be part of the longest chain. So we can't have the methyl move to the left. It'd be part of the longest chain. It'd be a butane. So if I move that methyl to the end, we'd have something like that. That'd be 4 in a row. Okay. So the correct answer to this is the only possible methyl propane is in the 2 position. So you did not need the number. You can never have an alkyl group at the end because it's not a branch if it's at the end. It's part of your chain. So methyl propane is the answer.